Forgive me for sometimes being a bit slow. I woke up at 4:50 in the morning for getting my train to London, so it's been a busy day for me. A bit of about myself. By night I kind of spent my time working on DevOps and organizing DevOps days, writing blogs. I wrote a chapter in the web operations book about monitoring, and I kind of hack with Vagrant and Vivi as a project. That's by night. I do tweet a lot, so that's the only Twitter slide I guess I have. And by day, I currently work most of my time for Atlassian, known for Jira and Confluence and all that stuff. And I also work sometimes with the Qcon Consortium, which is a kind of analyst company in the US, which is also pretty known for agile consultancy as well. Okay. The story I'm going to bring, it's about a project in this big traditional enterprise. I don't know how many people work in traditional enterprises here. Raise your hand. A few? Okay, that's good. So there's always a group within those enterprises who has to be like the most innovative group and has to move the things forward and save the business and save the company of doing great stuff. So it was a very similar experience. The application we sent out to be making was a real-time TV web interaction. So you would have a TV show where the host was actually interacting in real time with social media, getting questions. When he asked questions on the show, he would feed them in real time to people on the show and getting that back. So that was kind of the challenge, to make it in real time and not a separate forum where people could chat and it has no relationship with the TV. So if you ever have some relation with TV, real time and failure, they don't go together well. So it's a challenge to get that going. The interaction was actually with a technology they called second screen. Within Belgium, the provider of internet and the setup boxes that run over it for the TV, they don't expose data about who's watching what to the actual broadcasters. So they have all the data, but it's kind of closed. So the only way they could figure out to get some interaction was synchronizing a second screen where more and more people are watching TV with a smartphone, a tablet around to kind of do their real-time interaction. So they can measure what's actually happening. So it's not, you could get probably the same information from the TV viewers or the broadcast, let's say the telecom providers, but they didn't want to open it up. So that was part of bypassing these people. You go to real-time second screen applications. So within those big enterprises, you have all these servers running, and they always say, oh, we can do everything you want. Just come to us. We're ready. And then that group just said, you know what? We have 1 million TV viewers concurrently, potentially. I must say it was a research project, but it went on prime time. So it's, in a way, we were allowed to fail, but we weren't allowed to fail very much because it was real time. So it would be very bad for the brand if we could go down. So the investigation was, how can we scale this up if a show has like 1 million viewers that are doing voting, interaction, telling stuff in a peak moment of just the program? And then I guess the group within the enterprise, they just got like, whoa, this is... We can't cope with those peak loads. This is like insane if we start doing that. So, well, yeah, there's always a clever guy within that group of developers who said, okay, let's go to the cloud. This is what it's made for, peak capacity, let's do it. This is the easy way to do stuff. So what they did, first prototype went live of a kind of questionnaire interacting on Google App Engine. It was pretty okay. The usage, because it was the first time it was promoted and wasn't like heavily promoted, but just a few pings to the audience, like you could interact. So you can see there's a rise for the geeks, and it's not the mouse, but there's some people starting to use the application. And what we figured out is that the whole abstraction of a pass is pretty awesome. Like, you don't have to care about the servers running around under it, and you just deploy the application, which is pretty cool. But then when the load started going up, there's some, at a certain moment, there was just like traffic went down. What was happening? Later, we understood that it was like the kind of scaling that kicked in on the pass that temporarily, during the show, made it unavailable, and then it was rescaling, and then it became available again. So this is internals of the cloud, like the pass solution we're running on, that we were discovering in real time, which is not something we really want to have. And the other thing was, we could run some Python code, but again, it was research. So we had this all crazy, whatever tool we could think of, that we wanted to experiment and learn with it. And we didn't want to only run one tool, because then we would be constrained to what that tool was doing very well. We wanted to pick the tool that was good for the job. So we were using some Java code, because the libraries that we were doing of coding the stream was very efficient coded in that, so we didn't have to reinvent it. But we had some Rails as a front end, which made it easy to prototype like new interfaces. And then Node.js was the saver in dealing with the peak loads and not making it overload, because what do you use? Well, on the Rails front end, we would have the problem that the GIL was actually locking, and the concurrency was kind of hogging when the load went up. So Node.js and Eventant was a better fit. The same thing with the storage. We wanted to have a very fast real-time database to kind of get the counters, who's watching what, to keep that alive. So Redis is very good at that. But for the long term, like when all the traffic was going on the site, we wanted to have a very more analysis, who at what moment did what. And so we figured out that we needed a different storage. And then somebody came around and said, well, I want to run reports like viewer statistics and do that in real time, but also after the show. And then they had all these ETL tools that weren't able to kind of work with that. And then we had to export all the data in a MySQL or SQL-like database, because they're only talking GDBC, ODBC. So you see, the whole different stack just required us, like, a pass is great. Like, we got the feedback that it's working, people are interested. But after a while, it's just like, we need more flexibility that the pass is actually able to provide us. So more control. We went to just pick infrastructure as a service, and that's it. So this is about when I joined the team. They said, we're running on the cloud, we can do stuff, but we need a guy to take care of the infrastructure, because we've never done that, and we used to just run the applications. But I never did any cloud stuff. It's amazing I even was on the cloud panel, but okay. I did some enterprise stuff, which is, I guess, at some scale that makes sense to kind of know the relationship of the problems we would be facing. So I tried to explain to the team the things I learned about managing production service in general within an enterprise. So it might be that you're already doing these steps, which is great, and I'm sorry for that, but there's a few steps how it kind of build up. I don't know what it is, but within development, you have like this one machine that you kind of got from somewhere in a stock, and then you start running things on it. So they were used to run several stuff on one machine. So what I learned in production, that these things started growing, and they're actually harder to debug, because that web is interfering with the application, is interfering with the database on the same server. So it gets hard to kind of pinpoint where the problem is. So what I've learned is that you split off these services across dedicated functionality, and they do one thing well, and it kind of simplifies your debugging and where you're actually having to look for your problems. Of course, we don't run on physical if we can run on virtual, which gives us flexibility to kind of easily create. I guess most people know that. And because we're running on the infrastructure as a service, we're already running on a virtualization layer. So that was nothing new there. They started using AMIs to do cloning, like you install one and then you clone them and you go to the other. One thing I learned again from the enterprise is that cloning doesn't work because you have to fiddle again with the config files and do all that stuff once you start cloning that. Do you guys feel familiar with that problem? Right. Who's still using cloning today? Who dares to admit 1, 2, 3? Okay. So this is where the concept of configuration management steps in. Who's familiar with configuration management? Okay, that's good. So the idea is minimal installation and get your config management to configure your specific parts. So you don't need like this bloated image or cloning. You just use those levels. I guess this is what an AMI in the essence is. Like it's a base operating system that you start building up. So nothing new. I could handle that in the cloud without any problem. We put all our code of configuration management in a code repository. We use Git. And okay, you can pick your own configuration management, CF Engine, Puppet, Chef. So how many people are using Puppet here? Few Chef users? Okay, both? Okay, I had that ID. So there was nothing special. I could just manage whether it was on the cloud or it was in my enterprise. There's no big deal for me. I just use the same principles, reuse, no problem. And I also learned that it's not only for production. So I just apply the same things for my test environment, which makes the reuse very easy and to have it completely configured the same. In internal enterprises, it's usually a challenge to get the same infrastructure for your test environment as it is for the production. Within the cloud, they're all more or less the same. Still, your capacity might vary, that you don't allocate the same number of machines as you have in production. But still, like from a reproducibility in the test environment, the cloud was a perfect fit and applied very easily in that pattern. But then you will often see that some group is running the production, and then people are testing, and they're kind of spawning off all these different test environments, which is hard to manage, and kind of what's happening, who started what's running there, can we shut this down because it's costing us money on Amazon. Internally, it's less of an issue unless you're having a limited amount of resources, but still, you have to figure out like who's spun up some VMs, or what's it doing, or why is it useful for. So within the enterprise, we would use something, UI front end, that kind of tracks, like when people ask for a new system, they start creating a new environment, and we kind of track that. Typical products within, well, let's say in the open source space, Cobbler, Spacewalk gets you into that tracking system that is kind of like through the GUI, you ask a new system, it's provisioned, it's installed, and you go from there. And then you kind of start tracking, as the systems are running, a kind of registry. Like, system went up, it's running these servers with these functionality, so a kind of registry where everything's running. So you could easily do the same within the cloud without any problem. You just reuse the same tools. So I guess nothing special yet. So, but I haven't done any cloud stuff. So how do you pick like a cloud? So what I hear from a lot of people is it's about hearsay. Like, what are you using? Oh, sounds good. Let's try something. And that's the same whether it's config management or the new cool tool you're looking at. You kind of listen into what people are using. But to really know whether it's the best tool for you, you kind of have to go through the experience of seeing what the issues are. The first thing, if you run on Amazon, you get this UI. And, OK, and they had an API. Whoa, but it was Java. It's, well, I'm not saying it's my forte, but the API wasn't very easy to use for me. And I never use a GUI, or I tend to avoid it if I can, because it just slows me down, like clickety-click, and I don't want to do that. So I heard that Chef as a tool was pretty interesting to kind of bootstrap and manage new machines on EC2. So with an easy CLI, I could say knife EC2 server create the role, the AMI, bam, and then I could log in. That's pretty easy, pretty handy. Like, I didn't have an equivalent in the enterprise world that would just say, whoop, provision this, and I get the server. I had the GUI, but I hadn't like flexibility. At that time, Puppet didn't have it, but they're like now having something similar, which is called Cloud Pack. Different syntax, but you get the same idea. You create a node, AMI, spins up on an instance, and you can sort of just SSH into the box and do whatever you want to do on it. It also bootstraps the Puppet and Chef client on it, so you don't have to kind of install Ruby and all the jams, just required to do the config management. So that's pretty easy. So that's something different I wasn't using within traditional enterprise, just to bootstrap environments. Under the hood, it seems that they're all using the Fog.io library, which is, I don't know if you know JClouds or Boto or Fog. They're a cloud abstraction library. So Chef and Puppet are using Fog to do server cycle management. But these tools also allow you to do a lot of other stuff. So what happened is that I was using these tools to kind of bootstrap VMs, but to automate the other stuff like creating security groups, keys, load balancers, and so on, I'm not saying scripts because this is in Ruby, but at least I was automating it through that library as well. Something I hadn't done as well in enterprises. I would stick to the server and never kind of automate these other like creation of keys and load balancers. That was kind of other group. So that gave me more flexibility of doing that. Running on EC2 gave us a new set of constraints. If you create a VM with a security group, it's there forever until you destroy the the machine, which seems pretty inflexible. Like, I was going there with an idea. If you think about a traditional enterprise setup, you have your VLAN, a machine has maybe multiple interfaces, and you kind of connect them to the backup LAN, to a monitoring VLAN, you plug them into the different sets. And now I had only like this one network interface I could allocate to. So my backup was going over it, my monitoring was over the same network interface. And with the security groups, I would think in a layer like front end, middleware, back end, and create like these security zones. But with the security groups, it was kind of different the way I needed to manage that. And something we found out a bit later is that we had WebSockets running, and we hoped to get it working over Elastic Load Balancer. We just couldn't, because it was a non-standard port that we're using because of some Flash integration, blah, blah, blah. And the Elastic Load Balancer, even if it's very good for HTTP and normal website, it just couldn't work for this because we had a new restriction. So it's almost like discovering all these things like, oh, it's cool, the cloud, but one by one, you see like the restrictions you have to be aware of. Another new thing that came up was with all these things now very easily spinning up on all these environments, to track like the configuration of what host do I need to monitor and what needs to be in the config files. Because the traditional config files of products within the enterprise are pretty static. And you change them by hand or something. And then, okay, you reload and it's there. But you can't do that for monitoring at that scale. You want to have that node automatically added to your Nagios config when you spin it up. You don't want to go by hand because it's additional steps. So Chef has this nice concept of doing searches across host names or environments that you can use in your recipes or manifests in your config management, and just say, list all the hosts that are applied to that list of functionalities and just iterate over them and write my config file. So whenever something new comes up, it's just reprovision the config file and it's there. So that helped pretty much. I didn't understand the power before I went to the cloud, but now I see the value of just having that dynamically going up as well. Then the next thing. Maybe you don't experience the same problems I do, but occasionally spinning up a new VM, it's just like waiting. So it's not even guaranteed that it's spinning up a new VM. Or networks all of a sudden go like, no bandwidth. I hope you never encounter them, but I doubt it. So it's again like this new set of constraints you're learning while running on the cloud. And I don't know if people warn you for that, but it just happens. The same with disk. Writing to disks, you can just have varying performance that you don't know. So especially imagine real time. This is not fun. Like if this happens during a show, you're kind of, oh, what's happening here? So something we learned one time the hard way. So you have to have actually a new model. I think I'm not the only one to say that. Embrace the failure that you kind of assume because you're going outside an environment, or you're outside your own environment to a kind of unsure environment that you kind of have to think like, these things can fail. And you have to kind of work through them differently, like redesigning the way you do stuff. Right? So within the enterprise, you would say, let's build a cluster or something like with a failover and do that stuff and multicast and blah, blah, blah. Guess what? There's no multicast on EC2, and you have to find your own solution. So you kind of have to reiterate, like you're in a new environment, new constraints, new architecture, even though you would think like it's just running on some virtual environment. What could be different? But and then because things start failing, you start monitoring the other one because you want to know when it fails. It's not only your stuff, like is my application down, but you start monitoring whether the disk performance is okay on that box, whether it's provisioning, whether everything is sane. So even though they say you don't have to worry anything about the lower infrastructure, you start caring again because you don't want to know what state it is in. So that makes me always laugh when people say no ops. I guess you can be like this and say, okay, we don't care about what the rest is doing in our environment. But when you do care, you start like seeing and monitoring the world, whether anything has changed and whether we have to change ourselves. So that's the way, at least, I look towards NoOps. As people are calling it the nirvana, where everything goes smoothly and you don't know if to worry. I hope so, but I doubt that it will ever happen. And it might not be on the lower infrastructure. It could be a service you're calling from a SaaS provider. You need to monitor whether they're available or not. So it's everything that's externally, you kind of still have to be aware. And within your own data center, you can think like, okay, I control everything. I know what's happening. Of course, you still need to monitor, but you're less concerned about monitoring what you're actually depending on. So what did I learn when running on the cloud? Besides those little like things like, okay, it's different context. So for these parts, I see not a lot of difference. We're running it. We have config management, some metadata registry, GOS, VM somewhere, and a console. I did learn about a console turning into an API, where it's very flexible to create that stuff. So if I go back to my enterprise, I'd rather try to offer an API also internally for my internal customers. Could be developers, could be another group, could be external parties, but to expose that as an API and not just as a console, because I can see the value of that flexibility. I learned to go beyond server components, that everything can be dynamically changing, and I don't have to be focused on one part. And I also learned about provisioning a whole stack. At that time, CloudFormation came out, and it was very interesting to say, like, 5 servers of this, 3 of that config, 2 load balancers, here's a JSON file with everything created. It wasn't working very well, but the concept was good. Why wasn't it working very well? Because if you do a lot of things at the same time, they have a rate-limiting API, which I know is evil from this morning, that kind of block you if you do too much. And the other thing is, if one of those things fail, they have a default policy that they roll back the whole stack. So there's no way of doing a run again for the things that failed to get it in the correct state. It's almost like you create it, and then they just stop managing it as a stack, and then you can start managing it again as an individual component. But it kind of doesn't get to the point like stack up, stack down, because I kind of missed that. So we had test and production running with a few differences. And obviously, those people were developing for that platform as well. So you'll see the similarity, like one host running everything, virtualize it, within the virtualization, split off the tasks. So the very same things apply if you start running on your development laptop to get the same setup. So because you are going to hit the same problems. It's easier to debug. It's easier to create up and down very easily. You make some config management, and hopefully you can reuse the ones from production, because then you don't have to figure out how to put up a Tomcat or something. Somebody has already created something for you. So you reuse that code across environments. We kind of love Vagrant for the fact that we kind of can reuse all that stuff in one tool, and which makes it pretty easy. So Vagrant is a Ruby tool, Ruby gem, that allows you to have a very simple CLI, which says up, provision, halt, destroy of a box. And during provision, it would do a run of your config management. You can check the whole, it's one file, you can check that into your version control, and you have like, say up, and it creates the whole box from scratch on your laptop, configured as it would be according to production. So we kind of like that system. Who has been using Vagrant. Quite a few. Some people happy with it. The new one just got announced, 1.0, major leap. So yeah, it's pretty cool stuff. And we just started even integrating Vagrant in our continuous integration, like the up, down, and so on, made it pretty easy to have it hook into Jenkins, like up and down the VM, build it, run test, dispose, go up again. That really helped. So that simple workflow, it's amazing how it can change you. Because you used to have to configure file 1, 2, start up that service, do this, then create, use these horrible CLIs to create VMs that are never used for to do that. And so the simplicity just is so easy.
Quick question. You mentioned CloudFormation earlier. So I assume you had a setup where you needed to spin up multiple things. What are you doing with Vagrant? You just have 5 boxes? Or?
So we started out by having multiple VMs within Vagrant, but it kind of exploded. So that's the next slide. So running this complexity like in a Hadoop cluster with a Redis and a MongoDB on that one laptop, it kind of didn't fit after a while. It did work if we started running again things in the same VM and kind of optimizing and changing and optimizing for memory and CPU. But it kind of hurt after a while because we wanted to have this better integration. And we were depending on several services internally, so we wanted to have that feedback. Even if you would say, let's create a mock-up or something, but we just want to have the real thing, if it were possible. So in the end, what we did is we created a very simple CLI, McCloud. I'm not saying it's production ready. The code's out there. I use it all the time. But it gets you in the same workflow. Up, down, provision. But now on Amazon. So it doesn't really matter anymore. I just follow the same workflow. And because I was deploying all the time and testing it and destroying, I get a lot more feedback, even during my development cycle. So to give you an idea, well, it's pretty strange, but I got a request to shut down all my VMs in the evening because there was no need to have them all, the whole stack running all the time on Amazon. So every morning, I just practice complete deployment. So I wasn't scared anymore. I knew this is going to work. Every time I do this, destroy in the evening, pop it up. And even if I started when I did commits, before I would do a commit, I would destroy everything, test, create it again. If it works, then I would do a commit. So it almost gets you in a different mindset when you start doing that.
How long did it take, by the way, one of these cycles?
I guess it was about 5 minutes. For, let's say, the complexity was about, let's say, the one stack and not the scale stack, about 15 to 20 different components running. And every developer could have their own stack. So we namespaced it within the same account with prefixing the names with a kind of label like this is development of user X, and it would just filter out all the machines so he didn't see the others and kind of make that happen. So that got pretty powerful. Just that workflow, reusing that was very nice. So then I said, well, we have some of these boxes lying around here internally. Could you use them also? Because we're paying this loads of money to Amazon, but we still have some spare hardware here. For running some tests, it also makes sense if you could do it here. Sure. So I extended the Fog library to have KVM support, because then I could use KVM internally with the same tool. And I would just say my provider is now KVM, and for production, my provider is Amazon. I just switch from one to the other. You could say my provider is VirtualBox in my dev, KVM in tests, production is AWS. And I would just use the same bootstrap scripts. I would just use the same configuration management on all these different platforms. So in my opinion, what I'm seeing happening is that these cloud libraries that make the abstraction, they used to be very focused on this new, what I call new cloud. But more and more, and then they kind of went to hybrid, like internal, external, but even still a cloud product. They all started adding the old virtualization layers too. Like Fog has now vSphere, KVM through libvirt, but you see there's actually not much of a difference anymore because it's the same thing you do. And if you go to the personal one, I created like VMware Fusion that does the same, like creates up, down, destroy, lists the servers running on my laptop. So I'm just reusing the same thing. And the more you do something with the same way, the more you're testing actually your workflow with the same things. And that gives you a good way of getting the feedback early because you're actually doing the same thing. A little plug for a project I'm working on, which is Vivi. Again, it's abstracting OS installation. So all these OSs, Debian, Ubuntu, they all have another way of automating installation. So same principle here. You kind of abstract and you say, let's create like bootstrap or create a command that says up or create a base image. And whether it's Debian, Solaris, or even Windows, you're just using the same things. And it's all from source. You can check it in. Everybody can reuse the same box. And the presets and the kickstarts could be the same you're using in production because they're actually no different. It's the same boxes that are configured. And then again, using the abstraction libraries like Fog, JClouds, and Boto, you kind of are able to manage them to create the VM and then run the installation of the GOS in an essence, and then run the config management and so on. So you see, you can just reuse that across the multiple systems. And even beyond servers, because there should be no difference like creating different DNS servers in your company or on the cloud. You would be able to create that abstraction as well, and you just make it easy to shift for the creation as well. So the command the group loved most was the command McCloud sorry. So imagine you're doing the real time. We had like this interim guy who volunteered to do some support during the down hours. And they came to me, so what's the procedure to actually shut down and put everything like it's not working and sorry page and blah, blah, blah. I say, just type McCloud sorry. And it configured like the load balancer is in the correct state, shifted over the servers, and that's it. So just that power of the CLI by automating it was so easy. I'm not saying that will help you solve the problem, but at least it's a no-brainer of just having that in a state that you want it to be. We were lucky because we didn't have to be online all the time because it was during the TV show a bit before, after, and we had possibility of downtime. But still, we found out that people just kept on chatting all the time. So in the end, we kind of went for the 24-hour support for the whole discussion. So self-servicing, I just want to get like a server. I get it now. I want to install it with this config, this stuff. I can just drive that, like from a self-servicing point of view. Something I haven't seen happening within an enterprise, but I can really see the value. So I'll start making sure that even with traditional technology, this will be more possible on places I come work, instead of just having a UI and say, okay, let's do some demand and get some approval and kind of make that self-servicing. Because it actually gives you that feedback cycle. So if I want to test something now, I get a machine now. And so I don't have to wait. So building up confidence while you do it, like I said, I create the stack up and down, and I already practice it 20 times in my dev environment. So, okay, there could be some constraint that is different, but at least I practice that part, and I just get that confidence level up while doing that. And to me, that's part of the essence where DevOps is just that faster from left to right to kind of learn what you're doing. So we talked about infrastructure as code and the similarities that we could do. One obvious thing is, like, you get into this mode, like, I change something, I do provision, I run a test, and then it works. And I do that in a very similar loop as a TDD. It's still slower, because creating a VM, it takes time, and you kind of, it slows you down. But at a certain moment, I was just having something like guard, or what's it called, send test or something, that just continuously runs, checks my Puppet code, and then runs when my code is actually green of the unit tests, what I call them, that their syntax is okay, that there's some classes included and so on, and then I run it on the server. And I get that feedback loop already. I'm not saying it's as fast as running your TDD test, but at least you get in that same cycle. And then there's the similarity of getting your monitoring up when you kind of say, I start by creating something that checks it on the network, whether it's up, and then I write the code, I deploy it, and then my monitoring goes green. It's very similar to TDD as a test, but now it's in the monitoring. So we started writing monitoring checks before we actually started writing the code. So we can actually see if they went green. So every change, no, not every change, but every new functionality was complemented with a monitoring check. So we could actually see if that was still working. To take that beyond let's say the test as such, I believe there's a relationship in gathering metrics and doing debugging in a way that you want to gather as much information as possible to kind of solve your problem. But it's the same thing people in production are trying to do to kind of understand what's happening on the network. So it's very similar in my perspective. So, and this is more, we didn't do that at the project I was talking about, but this is the stuff I'm working now at Atlassian on. It's kind of running on battery power. Okay, who has? Yeah. Okay, let's get the battery. Embrace failure.
Where's your backup? You're going to spin up a new presentation?
That's my backup. So this is the stuff I'm currently working on. So in the same perspective, like I want to spin up a VM here and there and use a different system, why can't we have the same thing with, I'm going to monitor my production environment the same way as I do my test environment. Like I install one of these tools, Nagios, it doesn't mean, well, it's more of a metrics I'm talking, not of a functionality check, but here it's more collecting all the metrics, not differently. So why can't we just extend it to the development and expose all the metrics that you see running on your box the same way with the same tools as people are doing in production? Because then you kind of, what I often see happening is that they do some testing and profiling in this environment, and then they're running here, and they have a failure, and they just use a completely different set of tools that these guys have never seen, and it's kind of get hard to kind of discuss what's actually happening because they don't know how to query the tools and so on. So I kind of very similar to infrastructure as code that we started to reuse in these environments. Why not just do the same thing with our monitoring tools? I'm not saying it's going to be one of those tools, but we could just get into the idea of why should it be different in these environments. And the same thing with logs. If you would count the number of ways people are kind of spitting out logs or thinking of their own time formats, or I don't know, it's just very similar. I want to have a tool that kind of makes it possible to go through the log files. You probably know Splunk. There's two open source one, Graylog 2. It's actually a Logstash that allows you to just index all the log files you get, and you can able to search them and query them on your laptop. So imagine you using the same tool when you have a problem on your laptop, and when there's a problem in production, I just gonna expose that information and say, you have access to all logs. Please check, search. And you don't have to learn two tools because you're reusing the same setup and the same functionality. The same thing is like the self-servicing. If I want to have a new metric in my application, does it actually show up in my production tools? So I want to have the self-servicing possibility of developers being able to inject new metrics as they see fit, because they know the internals of the functionality they're developing for way better. So if they start injecting it themselves and they can have it show up in one of the tools we previously talked, I'll again have a win in production, because it's not like I have to rewrite it because it's in a different language and it's a different tool. I get that benefit as well. So a nice example of enabling that is StatsD, a tool that was released by Etsy, which allows devs to kind of submit their metrics to a service that in the back translates it to Graphite internally. And here it keeps states like counters and all that stuff, so you don't have to worry about that in your code. You just get all the metrics fed into the system. And why not on alerts? If I want to subscribe to something's happening, like think of it like a breakpoint. When it reaches this, I want to be notified. So why can't we have that in production? Like, if this happens, send me an email or subscribe me to it. So it's kind of the same thing, like self-servicing the way to alert me if certain events happen. So Tettle is doing some work on that, is kind of make that self-servicing in a way. Graphite has done a great way of creating graphs. Just if you have all these metrics, just pull some graphs together and make random graphs as you understand what all the metrics do. So you can't have a magical thing that spits out a graph that makes sense. You still have to think about it. But it used to be harder because the metrics used to be static, like the config files of Nagios. They used to be predefined, but now they're dynamically injectable and appearing in the UI as something you can select to create a graph of. If you think this is like still way off, I think if you look at, again, what's happening in the cloud, okay, we have application deployment, continuous integration, but okay, what's that load testing thing again? I don't recall, but to give you an idea, you sign up with your Facebook account to a load testing service. And instantly, you get a code and says, now you're able to run 1,000 concurrent sessions for load testing worldwide. So how's that about self-servicing? Just running tests on all different regions of the world for nothing. That's what's already out there. But how do we bring that back into our enterprise, like if you want to do that kind of stuff? Pingdom, New Relic is probably, oh, okay, it's Blitz.io is the load testing one. Application metrics, New Relic is already known for getting a lot of metrics and getting them exposed. My only issue with New Relic is, and I guess with a lot of these tools, is that it's very easy to get data in, but to get it back out, if you want to relate it to something internally in a company, they're not very well made for that. So I would rather have something stream back to me or able to split like the information going out, but also feed it internally if I want to have it. They do a great job. I'm not complaining, but it's just a general observation. It's easy to get data out there, but not to get it back in if you want to relate it to private data or stuff you already have. PagerDuty for rosters and alerting is pretty cool, and logging, like the Logstash. Logly is a service. Just send your logs, you make it searchable. Very easy to do that. So my dream library is to create something like Fog JCloud, but then for monitoring tools. So why shouldn't be different? That I can just reuse and say, now my provider is Ganglia, and it's the same to send an alert event. I don't care. And the ultimate would be like monitoring up, that somebody doesn't need to worry about getting in his development environment monitoring up. It should be self-servicing, damn easy. Hopefully reusing the same logic and configs as it is in production, so it's already getting testing. But this is, well, at least I haven't come across out of it, but this is where I'm working on, because I believe the whole focus on configuration management and faster and deployment is pretty nice, but to get the feedback from the metrics and the monitoring and to kind of get them all back, because it's all events that's happening, whether it's a log file or something in your process you did, you don't really care. It's all events that are happening. And because you want to, what I call, maybe not the right term, but social IT, in a way that we share whatever we have to whatever another business unit needs to be able to do. And okay, I talked about Nagios and Ganglia, which are typically used for technical metrics, but imagine it also for the business metrics, that you can relate to the technical metrics and get that all. So you get the business, the feedback, whether somebody's using it, how they're using it, what problems did they have, and get that back. So for me, okay, internally, you don't have the unlimited resources as the cloud has. That's, I think, a fact, unless you're like maybe a cloud vendor yourself, but but I can still think like you can just reuse it the way internally as you would do flexibility on the cloud. You saw there's really no technology stopping you. It's just the mindset of making it more flexible and kind of using the same tools. So I guess relating to my title, the cloud as such, you can also abuse yourself. If you don't use config management, if you don't use the auto-scaling, and you start doing it by hand. So it's very similar, but if you get the right mindset, it's just very flexibility you can get internally as well. So that was it. Questions? Thoughts? Stupidity? I mean, this being stupidity?
Why the cats?
You don't want to know.
What's your thought on the stability of Fog at the moment? As a project, do you think it's considered production ready?
We use it. I know others are using it. I guess it depends on the provider being stable or not. And then another common thing that will happen is that if a cloud vendor himself will upgrade or do something that changes actually the API, then you might hit a problem. But usually they're pretty well announced that these things are going to happen. But yeah, it can happen.
So we had an issue where we had that situation where there was a lag between a cloud vendor changing their API or their feature set, in this case, ends, for catching up. And that causes a problem because we had to explain to our client we had this dependency on this thing that meant that we couldn't deploy. And obviously that doesn't look too good. So we obviously had contingencies and we could do it manually, but it kind of highlighted to us the risk of, the abstraction is great until it...
Absolutely. So that's the problem with all abstraction. But at least you can, it's open source. I'm not saying this is another thing, but if something isn't supported, and I guess we had the same discussion, is Fog actually exposes the underlying stuff, which is pretty nice. And most of the case, it's just like abstracted away, and you can't reach like something under the hood. If it's not there, you can still like get to it, and I like that. And don't get this wrong, but being cheapo and using a library, or maybe paying somebody to fix the library so everybody could use. Okay, what's your risk you're taking? Yeah. But still the flexibility of moving maybe from one to the other, yeah, it's a trade-off. Yeah, fair point. Other questions? Anybody already doing monitoring up in his company that way?
We bake monitoring into our AMI.
Okay.
Every developer just gets it. They just start their service and they go look for the graphs.
All right.
This is under config management, so we use Chef to just automatically detect new nodes the way you described.
Mm-hmm. Yeah, but that's you're running all on the, I guess, on one platform then. Like you're all running on Amazon. You're all running on the same.
Not only on Amazon, but for each cluster that we install, we have a monitoring node that takes care of that.
Sure. Yeah. But I think maybe another part of saying the monitoring up is that even in a non-connected way, I like to have him like use the same tools for his debugging, maybe locally, even if he's not globally connected. So he can just already practice using those tools. But this obviously, if you just think as your development as one of your environments you support, and you're doing it all the same way, there is no difference. But in a lot of companies, there's still this barrier, and then you kind of say, okay, even if there's a barrier, but I would be able to say monitoring up independently of them, but we're using the same config files, that will already give me a better feel of what I'm doing.
Does it mean that you're separating your monitoring per environment? Is that what you mean by monitoring up?
No, it's more like Vagrant Up simplified getting a box similarly configured easy for a developer to production. So in a way, I'd like to have like monitoring up. You could be part of it. It could be through the configuration management that actually configures something on the machine very similar, so that it gets like a light or full version of whatever you use in monitoring. So it could be part of that, but still I see sending events to a monitoring tool or a metric, that still is not something that's done by config management. And that also kind of needs an abstraction layer for me. Does that make sense? Yeah, I'll come back to you, sir. Yeah.
Maybe, I think it's interesting because we had a lot of talk about using some abstraction layer to be able to put together the same kind of things, bake them fresh, if you like. I would assume this is kind of based on a scenario where you have relatively lightweight tools. They're relatively easy to install. I can think of plenty of enterprise scenarios where you're talking about Tivoli or whatever. It's not something you're going to put in a monitoring up very quickly.
Yeah.
So,
well, it could be in a way that these tools are not running, let's say, in a local thing, but somewhere central, and then you just create like a link somewhere between that. So you could still use that for these kind of tools, I guess. Question?
You were talking about difficulty getting data back out of tools. We've been pushing vendors to add APIs so that we can suck data back out and then build our own integration for things like taking all the different alert sources. We have an alert gateway that sucks all the data in. And I personally kept hassling the App Dynamics guys until they added a REST API that could actually suck the data out. So if you're looking for a tool that has good Java monitoring and an API to suck the data out, go downstairs. But I've been driving that product to do what I need.
Yeah, but you have the mass to drive them.
Well, we're giving them the money.
Yeah. Yeah.
The end goal is that, making the product better for everybody that uses it. And every vendor, if you're building a tool that doesn't let the data get back out, then it's useless. So if it's an open source tool, go add an API to it. So that's the we've got to be able to cross-integrate all these tools. There's never going to be one tool that does everything.
One of the things I also like to see in this export functionality of data is to get the data back in an evented way or in a streaming way, and not having a poll and then delta and kind of figure it out, but just have it as a continuous stream running in. And I haven't seen that specifically, but so yeah. Other questions? Okay, so that's it. Thank you.